Ever feel like you're just drowning in information every single day? Trying to actually find the useful stuff, it can feel, well, impossible sometimes.
Uh-huh. It's a real challenge.
Well, that's exactly why we're here. Welcome to the Deep Dive. This is where we help you get informed, fast. We take the sources you give us, articles, notes, whatever, and pull out the key insights just for you.
And today, we're diving deep into something pretty fundamental, actually, in data management.
hmm
How we understand and categorize entities when we're modeling data.
Exactly. And for this one, we've got some really interesting material. It's excerpts from a discussion called 03 Entity. That translates to episode 3, Entity Classification and Selection.
Mm-hmm.
And it really digs into that vital first step in building data models, which
Mm-hmm.
is just figuring out what the potential entities even are.
Yeah, so our mission for this deep dive is really to get a grip on the basic principles for finding and classifying these entities. We want to help you, steer clear of the common mistakes
Right.
and really get why this first stage is so foundational.
And this isn't just for tech folks, right? Understanding these ideas gives you a clearer way to think about organizing any kind of complex info. Could be a database, could just be a complicated project you're managing.
Absolutely. It's broadly applicable.
Okay, let's unpack this then. Where does our source material say we should even start when we're hunting for these entities?
Well, the discussion talks about this initial stage as collecting FT candidates. Now, context suggests FT means financial transaction candidates.
Okay.
But the key thing here at this early point is to be broad. Don't get too analytical just yet. You're basically casting a wide net, gathering potential building blocks.
It's almost like developing a feel for it, isn't it? Like a knack for spotting them. The source even has that funny image of letters bubbling and calling out to their master.
Yeah, exactly. With experience, you start to see the patterns, those little signs that something might be an entity.
You get that smell test.
Precisely. And what's kind of amazing is that the source says with good training in this initial collection part, over 90% of the first batch of candidates can actually be correct.
Wow, over 90%. Okay, so it's really worth focusing on getting that initial list right. What's the first rule of thumb here?
The source really hammers this home. When in doubt, include it. Just put it on the list as a candidate.
Okay.
The thinking is it's much better to be inclusive at the start. You can always look closer, refine the list, or even throw candidates out later on after you investigate more.
That makes total sense. Better to have it on the list and discard it than miss something vital. So, okay, we have this initial broad list. What's next? What should we keep in mind?
The discussion then highlights defining the size of the entity properly. But at this stage, the main focus should be on the qualification. Does it have attributes? Does it have characteristics that describe it?
Ah, okay. So does it have stuff associated with it?
Basically, yeah. And you shouldn't get bogged down in all the super detailed exceptions or weird scenarios too early.
Right. Don't go chasing rabbit holes immediately. The source warns about getting sidetracked by those exceptions that might occur once in 10 years.
Exactly that. If you dive into those super specific edge cases too soon, you just get mental overload. It pulls you away from the main job, which is identifying the potential entities and their core features.
You end up focusing on the tiny details before you even have the basic structure down. Okay, so collect broadly. Check if it qualifies by having attributes. Don't obsess over rare exceptions yet.
Got it. What about when we find terms that seem like really similar?
Yeah.
Happens all the time in business.
Yeah, that's a big one. Navigating synonyms. The source points out that terms that look identical, maybe product and item, shouldn't just be tossed aside as the same thing right away. They might actually stand for different concepts in that specific business context. That's the key insight. Seemingly similar words can hide different meanings you need to uncover.
That's a really good point. What looks the same on the surface could be handled very differently by the business. So how do we start to, untangle these? The key is to get a basic primary understanding of what these ambiguous terms actually mean in this context. The source gives a great example from semiconductor manufacturing, super complex domain, right?
Yeah.
You might have terms like process, step, oxidation unit, but they all translate to the same word in Korean.
Whoa, okay, that sounds like a nightmare. How do you even start to tell them apart then?
Well, the practical approach suggested is to sort of elevate the concept, make it more universally understandable. Think about the analogy they used.
Yeah.
Subway stations. You've got
Yeah.
City Hall, Seoul Station, Shinshin Station, distinct stations, right?
Right.
But they also belong to different lines. Line 1, Line 2. And one station, like City Hall, can be on multiple lines.
Okay, yeah, I see where this is going.
So the key insight is that these terms that sound similar might just belong to different higher-level groups or categories. And you need to figure out what those categories are.
So with the semiconductor terms, you'd ask something like, okay, which category does process fit into? Which one is step? Trying to find that higher classification.
Precisely.
Yeah.
And what's fascinating here is how that subway analogy helps clarify things. A single point, City Hall, belongs to multiple higher groups,
Right.
lines. You need to do the same mental sorting for those technical terms to see their unique roles.
That is a really useful way to visualize it. Are there any other analogies that help with this initial understanding?
Yeah, the source gives another one. Beads, strings, and necklaces.
Okay.
So individual beads are like a basic concept. A string of beads is a collection of those related basic concepts. And then multiple strings can make up a necklace that's an even higher level entity, grouping the collections. It shows different levels of how things are grouped together.
So when we hit a term like process, we need to figure out, is this like one single bead? Or is it a whole string of related steps? Or maybe it's the entire necklace, the whole big picture.
Exactly. It's about understanding the fundamental level the term represents in the business. You have to grasp that essential difference, like knowing the difference between father, uncle, and grandfather. They're related, but fundamentally different roles. Without getting that basic meaning right, you're just lost in jargon.
Okay, so we're collecting candidates, watching out for synonyms, trying to understand the basic meaning and level of ambiguous terms using analogies or hierarchies. Got it. What's a major pitfall to avoid as we move forward with identifying these entities?
A really big challenge highlighted in the source is fighting the urge to think in terms of processes when you're modeling data.
Oh, right.
The material really emphasizes this. Data models, unlike, say, flowcharts, don't inherently have a sequence or timing. A data model shows the structure of information and the relationships between data bits, not the flow of actions.
That makes sense. We're mapping static connections, not the order things happen in.
Exactly. The source uses this analogy. It's like switching between different diagramming tools or maybe different scripting languages. If you try to apply the rules and logic of one to the other, you just end up with confusion and mistakes.
Yeah, you wouldn't write Python using Java syntax.
Right. And applying process thinking to data modeling does the same thing. It hides the real static relationships between the entities.
This reminds me of that story the source tells about the design review at that big company, the ERD that wasn't really an ERD.
Yeah.
Here's where it gets really interesting. Tell us about that CFD.
Oh, yeah, that's a great illustration. So the expert reviewing this entity relationship diagram basically said, this isn't an ERD, it's a CFD, which they made up on the spot. Table flow diagram.
Ah, table flow diagram.
Okay,
Right.
because instead of showing the static links between the core entities, it was showing how data moved between tables, like a process diagram. Data gets received here, then it's approved there, then records get moved over to this other table.
So it was showing the data's journey, the steps, not the fundamental connections between the things the data was about.
Exactly. The data flow is a process, and that's important, sure. But the data model itself is about the stable, underlying structure of the information. The source really doubles down on this, focusing on who came first, or the order of events,
Yeah.
irrelevant for data modeling.
Right.
What matters is the static relationship. Like an employee and their salary have a one-to-many relationship. That's true regardless of when the employee was hired or when their salary was last updated. The relationship exists independently of time.
That's such a critical distinction. So we really need to consciously shift gears from what happens next to how are these things fundamentally connected? What's another common trap that trips people up in this early stage?
Well, the source material points out a tendency to get fixated on exceptions, really unusual cases. And this often comes from people with a programming background. Because in software development, thinking about and handling every single possible edge case is, vital. It's essential for building robust code.
Yeah, I can totally see that. Programmers are trained to think about all the possibilities to make sure things don't break. How does that cause problems when identifying entities?
Well, when users are describing their work, they might unintentionally steer the conversation by focusing on the most complicated or the most unique parts of their job. They might sort of inflate how important or frequent these exceptions really are. And that can lead to unnecessary complexity or even distortions in the early data model.
It's like they focus on the one in a million thing instead of the everyday stuff the model really needs to capture first. How do we gently guide the conversation back to the core when that happens?
The source uses a pretty good analogy here. Think of a congressional hearing.
Okay.
A skilled questioner when faced with a long, rambling, detailed answer, we'll often redirect the witness back to a simple yes or no question to keep the focus on the main point.
Ah, okay. Keep it tight.
Right. We need to do something similar when discussing potential entities. Politely but firmly guide the conversation back if it starts drifting into very specific, rare processes or exceptions.
So what's a good way to phrase that? You don't want to shut the user down, but you need to stay on track.
The source suggests saying something like, that's a really interesting detail, and we will definitely get to those specifics later in the modeling process.
Okay, so acknowledge it, but park it.
Exactly. It tells them their input is valuable and will be considered just, at the right time after the main entities and their basic relationships are sorted out.
That's good advice. Prioritize the foundation before adding the intricate details. Now, we've talked about not overcomplicating with exceptions, but what about the flip side? Are there things we might gloss over because they seem too simple or obvious?
Oh, absolutely. The source highlights this as a really common weakness, assuming that everyday terms like employee or customer or actor are just universally understood, that they don't need a formal, precise definition in the context of this specific data model.
That is surprising. You'd think customer is pretty clear-cut. What kind of problems pop up if you don't define these seemingly basic terms formally?
Well, the examples in the source really show the potential for big misunderstandings. Like, does a temporary contractor count as an employee in our system? Does a department belonging to a partner company show up in our company's department table?
Ah, right. The answers could be totally different depending on the business rules.
Exactly. These questions that seem simple can have huge implications depending on how you precisely define those terms for this specific data model and the organization's needs.
So even the most common words need clear boundaries. What's in the employee box for us and what's definitely out?
Precisely. The source really stresses that even obvious-seeming terms need that precise definition to avoid confusion and inconsistency down the road, especially when different people use the model or you try to link it to other systems. These definitions need to fit into what the source calls a framework of perfection, aiming for absolute clarity and shared understanding.
Okay, define everything, even the stuff that seems obvious. Got it. So what's the next step in really solidifying our understanding of these entities we've identified?
Well, once we've picked out a potential entity and started defining it, the source says it's really important to form a clear, core mental image for it.
A mental image?
Yeah, like a mental anchor. It helps you make consistent decisions about its attributes and how it relates to other things as you build out the whole model.
Like having a really clear picture in your head of what this thing fundamentally is in the business.
Exactly. Think about recognizing a caricature.
Yeah.
Just a few key features, maybe even exaggerated ones, are enough to identify someone famous. The goal here is similar. Identify the essential defining characteristics that something must have to be considered an instance of that entity in your model.
That's a great analogy. So the modeler needs this clear, consistent picture. What about the users, the subject matter experts? How do they help build that picture?
The source kind of positions the modeler as an investigator, right?
Yeah.
And the users are like informants. They provide the crucial information when the investigator asks for it.
Okay.
The interaction should be pretty structured, focused on pulling out those key characteristics for each potential entity. You want to avoid just letting the user sort of teach the modeler in a totally unstructured way, because that can lead to lots of irrelevant details and confusion about the core concept.
So the modeler guides the conversation, asking targeted questions to get the info needed to build that clear core image.
Right. Now, once we have a bunch of potential entities, how do we start organizing them? Understanding how they relate. How do we, categorize them?
The source offers a pretty handy 3-level classification system. Seed entity, which is sometimes called key entity, origin entity, also called main entity, and action entity or child entity.
Seed, origin, action.
Okay. This framework really helps to map out the dependencies and the roles different entities play in the overall model.
Okay, let's break those down. What's a seed entity? Seed entities are the real foundational ones. They can exist independently. They don't rely on any other entity in the model already being there. They're sort of created or defined on their own. Examples given are like an employee with a unique ID or raw material defined by its properties. You can define these without needing anything else in the system first.
Got it. The independent building blocks. So what about origin entities? How are they different?
Origin entities, well, they do depend on one or more parent entities existing first. But They're really central to how the business operates, and they often have lots of other entities that depend on them.
Okay.
The example used is a credit card. A credit card needs a customer, right? And it needs a product offering from the bank. So it depends on those. But then the credit card itself drives a ton of business activity, all the transactions. So it has dependencies, but it's also a central hub for activity.
Okay, so it relies on others to exist, but it's also a key player that other things revolve around. Makes sense. And the last one, action entities.
Action entities basically represent the events or transactions that happen because the main origin entities interact. They're often called the generated data, the records of business activities. A credit card transaction is the perfect example. It happens because a specific card, origin entity, gets used in some context, maybe involving a merchant, a time, a place.
So seed are the independent foundations. Origin are the central players with dependencies who also have dependents. And action are the records of what happens when origin entities do stuff. That's actually a really clear way to slice it.
And the source also points out, interestingly, that people with a programming background often focus first on the action entities.
Ah, because that's the transaction stuff they code.
Exactly. That's what they work with directly. But a really solid data model has to start with understanding the seed and origin entities properly. They provide the whole foundation and context for all those actions.
It's like trying to understand a family tree, right? You need to know who the ancestors are, the seeds and origins, before you can make sense of all the descendants and what they did to the actions. The source even uses that Adam and Eve analogy to show the lineage.
It's a good visual, yeah. Now, things can get more complex. As business domains get more intricate, you can actually have multiple levels of these origin entities, sort of a hierarchy.
A hierarchy of origins. Can you give an example of what that might look like in a business?
Think of a tree structure. You have the main trunk, maybe that's a core seed entity. Then big branches coming off it. Those could be origin entities at one level. And then smaller branches coming off those branches, those would be origin entities at a lower level, depending on the branch above them. Each level depends on the one above, but might also have its own dependence further down.
Okay, like maybe a product line is a big branch, then product categories are smaller branches off that, and specific products are even smaller branches off the categories. Each level relies on the one before it.
Yeah, exactly that kind of structure. Now, the source gives a really important warning here. Don't try to identify the descendants, the action entities, too early in this process.
Why not?
Because if you start defining those actions before you've clearly sorted out the different levels of origins, it just leads to massive confusion. It becomes really hard later to figure out the correct relationships between entities at different levels. The source has this funny but problematic analogy of a child entity getting confused and asking unrelated parent entities if they're its parents.
Yeah, okay, that sounds like a recipe for a tangled mess of a model. So what's the solution? How do you avoid that?
The key principle is called horizontal leveling.
Horizontal leveling.
Yeah. It means you need to clearly identify and sort out all the entities that exist at the same level in the hierarchy first. Get that level clear before you start digging into how they connect to entities at lower levels. It keeps the structure logical and much easier to manage.
Horizontal leveling. Nail down one level completely before moving to the next level down's relationships. That makes a lot of sense for keeping things clear. Okay, let's try applying this C-Origin action framework to some of the specific examples mentioned in the source material.
Okay, good idea. Let's start with customer. Seed, origin, or action.
Well, can a customer exist on their own in the system? Yeah, seems like it. You can have their info without needing another specific business thing first. So, seed.
Exactly. Source agrees. Customer is a seed entity. What about corporation?
A corporation can be a customer, but the source clarified it's not just a type of customer. It can exist legally on its own, right? Business registration. So also seed?
Correct again. Seed entity. It's a common mix-up, thinking it's just a subtype, but its fundamental definition is independent. How about contract?
Ooh, okay. A contract needs people or companies to contract, right? You can't have a contract with nobody, so it depends on other entities existing first. That makes it origin.
Spot on. Contract is an origin entity. It requires those contracting parties. Okay, product.
A product. You can define it, describe it, spec it out before anyone actually buys it or orders it. So it exists before the transaction. Seed.
Yep, generally considered a seed entity. Its definition comes first. Now, curriculum. This one sounded a bit tricky.
Yeah, it did. The source said it depends on the definition, didn't it?
It does. If curriculum just means the subject, like math, that's a seed. The subject exists independently.
Right.
But if it means a specific course offering like Math 101 in the fall semester that depends on the subject math and the schedule fall semester, so that definition makes it an origin entity.
Ah, okay. The specifics matter a lot there. What about something like payment due date? Is that an entity?
The source says definitively no. It's not an entity. It's an attribute. It's a characteristic of something else, like an invoice or a loan payment schedule.
Right. It doesn't exist on its own.
Exactly. And the source makes that point about entities being pure sets, either objects or activities, not a mix. A payer was the bad example, mixing the act of paying with the person paying. A due date is just a piece of data about something else.
Okay, no entity there. What about currency, like US dollars or euros?
That one's a seed entity. You can define USD, EUR, their properties, their exchange rates independently. The source also had that funny bit about the word call. A currency call relates to a seed entity, the currency, but a phone call is an action. Context.
Context is everything. Okay, moving on. Invoice. Entity or not?
Generally not treated as a fundamental entity. It's more like a document, an output generated, because other entities interacted like a customer placed an order for products.
So it's a result, not a primary thing itself. Okay,
Right.
what about the payment?
Payment itself, that's the transaction, the act of mold. So that falls squarely into the action entity category. It's an event.
Right. And the last one from that list, lawsuit. This felt like it could go either way.
And that's exactly what the source says. Lawsuit could be main, origin, or action. And it really depends on the business. If lawsuits are central to what the business does, like a law firm, it might be a main entity. If they're just occasional events for another type of business, it might be treated as an action. It's relative. Needs discussion.
Okay, so its importance in the specific business context determines its place. That makes sense. Now, let's dig into those more subtle examples. Distinguishing financial institution from collection agency. What was the key difference there?
This goes back to that pure set idea. The source argues collection agency isn't really a pure entity because its very name and identity are tied to a specific action, collection. It mixes the what it is, an agency, with the what it does, collects.
Like the payer example again, it's defined by the action.
Right. Contrast that with foreign exchange bank. Yes, it performs actions, lots of them, but it can be defined independently by its charter, its function, its status. Its core identity isn't solely wrapped up in one single action like collection agency is tied to collecting.
Okay, it's about whether the core identity stands alone or is defined primarily by an activity. That clarifies it. The source also brought up relational entities, using the insured in insurance as an example. What's going on there?
Right. So the act of being insured is a state or an action, but the person who is insured is an entity, a person. Now, in insurance, one person can have multiple policies, right?
Yeah.
And one policy, like a family plan, can cover multiple people.
Many to many.
Exactly.
Yeah.
A many-to-many relationship directly between the person entity and the policy entity. And standard data modeling practice says you need to resolve that. You typically introduce a new entity in between them specifically to represent that relationship. And in this case, the insured often becomes that middle entity, that relational entity. It links a specific person to a specific policy and might hold details about that specific coverage, like the premium portion or beneficiary details for that person under that policy. The source also called these major entities.
So, insured acts like a bridge, capturing the specifics of the connection between a person and a policy.
Got it. As we're doing all this identifying, classifying, what are the big principles we need to keep front of mind for a solid model?
The source really circles back to this. Defining the exact set of things that belong in each entity is absolutely critical, even for those common terms like customer.
Right, the example where customer could mean a unique person or each individual contract they hold.
Exactly. One company might count a person once, no matter how many products they buy. Another might count each active contract as a separate instance in their customer concept. Those different definitions lead to radically different data structures.
And if you're not precise, it leads to chaos down the line.
Total chaos. Poorly defined entities are like using fuzzy Lego bricks. You get confusion, data inconsistencies, massive gaps in understanding later on, especially when you try to combine data or analyze it. The source had that analogy of a movie where characters suddenly have weird, illogical relationships revealed late in the story. It just messes everything up. Yeah, you don't want those kinds of plot twists in your database. This source also mentioned things like overusing or relationships or having tons of I statements in code as warning signs.
Right. Seeing lots of OR relationships, meaning something can be related to this OR that exclusively in the data model itself, can often signal that the basic entity definitions might be flawed.
Mm.
Maybe you're trying to cram different process flows into the static structure.
Uh-huh.
And similarly, the source really dislikes seeing excessive IF statements in the code that uses the database. If the code constantly has to check if it's this type, do this, if it's that type, do that, it often means the underlying data model is ambiguous. The code is compensating for fuzzy definitions in the data structure.
It's like patching up a fundamentally weak design with complicated logic. The source used that analogy of different mobile networks with incompatible data. Frustrating.
Exactly. Data problems, integration nightmares, they often start way back in the conceptual design, in flawed entity definitions.
Yeah.
It's not just about coding bugs later. If the foundation is shaky, the whole thing is shaky.
Okay, so precision, clarity, agreed upon definitions are non-negotiable. Once we've identified an entity, understood it, classified it, what's the very last step in this initial entity work?
The final, really crucial step is giving it a good name. A clear, accurate name. Once you really understand its scope, what it includes, what its core characteristics are, the name should reflect that understanding intuitively and unambiguously for everyone.
The name should basically tell you what's inside the box, right?
Pretty much, yeah. The source gave that example, a collection of courses with subjects, schedules, teachers, students, but it was maybe initially named Education Schedule.
Which only captures the timing aspect.
Right. A better name might be something like Course Offering, because that reflects the core concept, a specific instance of a course being offered. It's more about what it is.
Course offering feels much more descriptive of the whole package.
Exactly. And there was that other anecdote about lumping miscellaneous sales items together with actual financial products like loans and insurance. They didn't have a good unifying name initially. But by realizing the common thread, they were all financial offerings of the business. They could rename the combined group financial products. And suddenly, boom, clarity. Everyone understood what was in that category without needing a long explanation every time. The name itself conveyed the meaning.
So define it clearly, understand it deeply, classify it logically, and then give it a name that perfectly captures its essence. That seems to be the path. This deep dive has been super helpful in breaking down something that seems simple but is actually quite complex.
It really is. It's a good reminder that just identifying and defining entities, that seemingly basic first step, takes real thought, careful attention, that conscious shift away from thinking purely in processes. But mastering this, it sets you up for a much, much better data model down the line.
And by getting these initial steps right, you, our listener, really can get a much clearer handle on complex information, not just in databases, but anywhere you need to organize things. You can avoid those common traps. And, this raises an important question. How well defined are the core concepts and categories in your own work or your projects, or even just how you think about things day to day? Are there fuzzy definitions lurking?
It's definitely worth reflecting on, isn't it?
Absolutely. So here's our final thought to leave you with. Think about the everyday terms you use, the categories you rely on. Are they really as precise in your own mind and in how you communicate them as you assume? What little misunderstandings or inefficiencies might be sneaking in because of those hidden ambiguities? Maybe take a moment to explore the underlying definitions of some familiar concepts in your world. So what does this all mean for you? Thanks for taking the deep dive with us.